Well, so the derivative. On your mark, get set, go. The derivative, 1/2. 3x minus 7 to the negative 1/2 times the derivative inside. So the derivative's over. Let me just take a look at this derivative here. Let me clean it up. I like to clean these up. That's a 3 in the numerator, a 2 in the denominator, if you don't mind. And I'm going to put this in the denominator. Do you agree with that?
Yeah.
It's all true. Algebra there. I mean, the first step was the derivative, and then the next step was algebra. But now, here's the question. I'm looking for critical numbers. So, when is the derivative 0? And you stare at this, and I've tried to teach you that it's 0 when the numerator is 0. When's the numerator 0? Never. So when is this 0? Never. So now I'm thinking, well, maybe there's no critical numbers. Well, hang on. When is it undefined? And it's undefined when the denominator is 0, and I can tell when that happens. That happens when this is 0, and that happens when x is 7/3. So I guess 7/3 might be a critical number. Now there's one little thing to worry about though. One thing about this definition is it says we're looking for these numbers that make the derivative 0 or undefined. They make the derivative undefined, but those numbers, they have to be defined in the original function. So just because you find this undefined thing, I don't know. Let me just check. Is he defined in the original function?
Yes.
In the original function, are you allowed to plug in a 7/3?
Yeah.
If you do plug in a 7/3, what do you get? You get 0. Okay, well that's okay.
Yeah.
So he is defined in the original function, kind of barely, by the way. Anything greater than 7/3 ain't defined. But 7/3 is defined, and he made the derivative undefined. He's a critical number. Let's do this one. Derivative, please. Oh, by the way, I just wanted to find a critical number.
Okay, I was gonna say.
But, well, we could go on, right? I mean, well, after you find a critical number, then what are you supposed to do?
Find a min.
Is he a min or is he a max? I don't know. Maybe put him on a number line. Maybe check him out. Maybe sketch the graph. I mean, right?
Because
Right.
it's less than that.
He's a funny one.
Yeah.
He's, okay.
I was doing the
All right,
first
so
one.
without a thorough analysis, if I just graph this function, it's one of these square root functions, and it starts at 7/3. It's an endpoint, actually.
Right.
That's what made it, that's what made the derivative undefined. He was an endpoint.
Right. So.
But he was defined in the original function. He's a critical number, and I don't know, just look at the picture. Is he a min or a max?
Min.
I'd probably call him a min.
Okay. So there's nothing
But he is a little
happening
funny,
Yeah,
huh?
there's nothing happening on the left of it.
Well, look at it. Is he a min or a max?
Yeah.
I mean, is he in his little neighborhood? Is he the lowest dude or the highest dude?
Lowest.
So he's a min.
So you would call it.
But he's kind of funny because he's an endpoint. I mean, I gotta admit. But my point was,
Find the critical.
I wanted to find a critical number that came from being undefined. So I created a function that gave me a critical number that's undefined. And I want to contrast it with this one. So he's a legit critical number, and it turns out he's a min, but I didn't care about that. But he's a legit critical number. How come? He made the derivative undefined, but I had to check, make sure he was defined in the original function, which he was. Because of this is an important part of this definition, kind of. Check this one out. Let's do this derivative. What do you think? Quotient rule? Sorry to take all your fun away. Quotient rule, right, kids? Derivative of the top times the bottom minus right down the top. Take the derivative of the bottom, please. Take the derivative of the bottom, please. Good job. All over the bottom squared. Right? Good old quotient rule. I'm going to clean up the numerator there a little bit and see what happens. I'm sorry, but I'm gonna move over here where I got a little room. I'm cleaning up that numerator over here. I get 6x squared minus 30x minus 3x squared minus 2. Wow. So I get 3x squared minus 30x minus 2. Is that right, you guys? All over x minus 5 squared. Okay, this is my derivative. Okay, I'm looking for critical numbers. What should I do? When does it equal 0? When the damn numerator equals 0. Oh my God, that kind of sucks. I mean, maybe I got to do a quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's 900 minus plus 24. That's the square root of 924 all over 6. What is the square root of 924?
30.4.
30.4. Blah, 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 blah. All right. Well, anyway, looks like I'm finding a couple critical numbers. I'm not going to bother to clean them up. Here they are. Those are critical numbers. They're two numbers. Again, don't let the numbers freak you out. Those are two numbers. And they're critical numbers because they came from
The derivative?
when the derivative equals 0.
Zero.
When the derivative equals 0. So these are critical numbers. Okay, now wait a minute. There's two questions. There's always two questions. When is the derivative 0? Okay, we've done that one. When is the derivative undefined? Well, hang on. When is this derivative undefined?
Denominator is 0.
When the denominator is 0. So this derivative is undefined when x equals 5.
Yeah.
So maybe that's another critical number.
Right.
Or is it?
Oh. Uh-oh. Now it's new.
In the original definition of a critical number, it says that whatever is a critical number might make the derivative 0 or make the derivative undefined, but god dang it, it better be defined in the original function.
Right, it's not.
Because if it ain't defined in the original function, what is it? Then it's a hole or a break or an asymptote. I mean, then it's not even a point. You know what I'm saying? If it's not defined in the original function. So this critical number we found called 5 was, where is the original function? Where is it?
Right here.
Yeah, it's undefined in the original function, of course. So he ain't a real critical number. This ain't a critical number. Are you guys okay?
If it's more than likely undefined, it's never going to be defined in the original number.
Well, we found one here that was. We found a critical number that came from being undefined.
Okay.
Right. When is this undefined? So here was a critical number that came from the undefined part of the definition.
Right.
But he did exist in the original function. He's a legit critical number.
Okay.
But this one came from the derivative being undefined, but he wasn't defined in the original function. So he ain't really a critical number. I mean, what is he? Back to the original function. There's a vertical asymptote at 5, is what it is. So there's no critical, it's not a critical number. The little technicality in the definition. It has to be defined in the original function for it to fall into this category. You guys okay? But I do have two other critical numbers. Might be good mins or maxes, who knows? I don't want to bother them, I don't want to go find them. All right, you want to quit? All right. You mean the whole course, or what do you say?
No.